So we have some very cool feature in Azure Maps called Azure Maps Creator, and as its name stands, it will help you create your own maps. Don't miss it. It's on the IoT Show with Roberto from the Maps team. Hi everyone, thanks for tuning in on the IoT Show. I'm Olivier, your host. Today we have an announcement for you, and it's about some very interesting mapping technology. And we have Roberto from the Azure Maps team. Roberto, thanks for joining the show.
Hi Olivier, thank you for having me.
So Roberto, tell us a bit about yourself. You already came to the show, but give us a little intro of yourself for those who don't know you yet.
Sure. I'm Roberto Lucchi. I'm a PM in Azure Maps, and I focus more onto private mappings and integration with IoT, location of things.
Awesome. So there's a great new feature we are announcing that is called Azure Maps Creator. Let's get in it. So what is Azure Maps Creator? What is it for?
Yeah, it's very exciting. We are launching this new set of capabilities for enabling basically customers create their own maps that represents the understanding of space they want to reflect on their mapping, and combine all this with the power of IoT and Azure Maps capabilities for that we already ship. Let me share my screen if I can. So I'd like to show you more in detail what we do at scale and securely within the Azure cloud, and keep that as a system of record. It serves the users who are looking for creating maps for indoor, as well as those who are looking for implementing smart building applications that make use of the understanding of space and the object within the space, as well as all the sensor data, IoT data that you can deploy in an indoor environment. And we basically categorize this function into a set of API that are serving as a mapping as a service, where you, for example, can take advantage of an automated conversion tool that takes CAD-generated data during construction and transform it. You can import multiple level of details. You can build multiple different styles, including dynamic, as things change as in the space based on IoT observations. You can bring that knowledge into the map. And then we provide API for rendering, query. I'll go through all these very shortly. And the SDK to help build more rapidly the application.
Cool. So that's super interesting, and I guess long awaited type of features. But can you tell me a bit more about CAD, and what is CAD? Is it like a common format for sharing data, and in what areas is it used today?
Yeah, so CAD is computer-aided design, and is a set of tools and products that are very widely used during construction engineering work for new building. And as they deliver during the construction or remodel phase, these floor plans, we can take advantage of this existing work to more rapidly build an indoor map.
I see. So I suppose that it's going to be a breeze, and you're going to show us that in a second, to integrate this existing set of data. And what I'm hearing is that this is basically kind of a standard in the industry for defining, these designs, documentation, and data. And so, well, I look forward to see the actual demo. How about we look at how that looks like?
Yeah, absolutely. Let me show you. So what you see here in this application, in this web application, is one of the map styles that Azure Maps today already provides, and you could even change for imagery and so on. But let me just focus on the capabilities we have been adding. With Creator, you can build your own private maps for indoor. And as I zoom in here, this is data that is augmenting the knowledge that Azure Maps provides with your own understanding and knowledge of your spaces. I can change floor. I can map different objects within the private map. And then I can go even further than this and provide additional layers. So I could add weather, which takes advantage of our weather API and weather forecast API, but I could also connect to additional sensors For example, in this case, we have temperature measurements that come from IoT, IoT Hub, more precisely in this case, and they are represented on the map as the data comes in. So I can switch floor and basically get an understanding using this symbology legend of the temperature in each individual room. And if I click on it, I can get an information about the more detailed data that is coming from the sensor, as well as forecast and data that is coming from our weather API.
Wow.
And this information, yeah.
Yeah, so that's building also on top of the other, as you were mentioning, other functionalities of Azure Maps already there, like the weather data and others. That's pretty amazing.
Absolutely. We can take advantage of that to, for example, improve energy management by knowing the temperature and the sun exposure that a building or a particular area of the building is going to get in the next 24 hours, for example. Absolutely. Yeah. And as you get more sources, you can even go further. For example, in this case, we would have people count that will tell how many people are within the room at the moment. So you can imagine this technology being used to represent many different solutions for smart building, ranging from office space to retail store, hospital, factories. It's designed as any other Azure Maps API to be applicable to many different contexts. Yeah. And of course, this is the result. I'd like to show you what happens behind the scenes.
Definitely. And before you jump into the behind the scenes, I have one remark, which is here we see a map that like people use to navigate, to their usual mapping application and they find information. But because we're using Azure Maps in that context to create an application, that data that you see here, the occupancy and so on, there might be privacy problems. Azure Maps actually totally takes care of all these privacy problems and data ownership for you, right?
Absolutely. The authentication method that Azure Map provides for shared keys or connection to Azure Active Directory are there for this function too.
Awesome. Okay, so developers were actually watching this. They want to see the APIs. They want to see how it's done. So let's see what's under the hoods here.
Absolutely. As I mentioned earlier, very often during the construction or the remodel, you get CAD drawings. In this case, I'm showing a Autodesk DWG file format, which represents the floor plan of a given floor of a building. And you could add additional information. For example, a useful one that is represented here is the extent a Wi-Fi access point cover as a signal is concerned. And this information that could be drawn first during design in a CAD file can be brought into Azure Maps through Creator. Now, you see here labels. Those are great, are representing the name of the space, and I will later work on this one as an example. This large open space here. But the idea is that you may have more than this. So what we do, in addition to being able to process CAD data, is to also connect to additional metadata. So we have here an example where you can provide business hours, contact information regarding the given facility, and then start mapping every file CAD drawing that actually represent a given floor. And you can go more and more into the details as you need for your application. So for example, in this case, each unit, each particular room could be equipped with a categorization of the space, whether it is navigable by pedestrian, if it is wheelchair accessible, every metadata you may want to add during the process. And I'm going to switch to the API that is able to get all this in and process it to create a map.
Right. So the creation of the metadata is something you would do manually. You're showing here VS Code, right? But that's something you would eventually import from another database or something like that.
Yes, very often it could already exist. For example, in Microsoft Graph, which is what is powering Outlook for meeting room management. It could be coming from a different building management system. So we define a model and an interoperable JSON schema that you can use to bring the data in.
Awesome.
And you see here, in this case, the process to actually create the map before exploiting in application is starting from an upload. In this case, we are uploading a zip file, a Contoso sample building, which contains drawings like the one I just showed and metadata. So you can upload this. This API is going to give you back a unique identifier, that you can use to basically reference this data later on. In this case, what we are going to use this uploaded data is for conversion API. So the conversion API is a very important one because it accepts drawings and metadata and goes through a validation process through which, if the data is correct, it's going to be converted and processed. If the data is not correct, you can get additional tool we provide to inspect the data and fix any possible data issue that you have in there. Once the processing completes, you get a very nice report. As I said, this is the diagnostic package if you want to inspect the result even further, but this is where you can get the conversion ID. This is where you can actually start making use of this data that is being transformed into map data. Now, the interesting part here is we just ingested the building. We may have a single building map application. We may have distributed over different counties or states or countries. We can support all this as well as campuses. So how do we do this? We have a dataset API, which you can use to basically import and keep appending every building you may want to include in the same map you are creating. So in this case, I'm going to import a given conversion ID, which is one of the facility, but I can keep adding those into the same data set. So if I want to build a map with a campus of 100 buildings or a hospital facility with 5 different buildings, I can keep appending those in the same data set. And this is a very powerful tool to essentially create a set of facility, a network of facility, and give them the geographic context so that you can also do routing across building and other type of applications.
So if I understand correctly, once you have the data set that has been created, then you can apply all the usual mapping and geolocation APIs onto that data set.
That's correct. And I'll start from a new one that we have just introduced, which is the Web Feature Service API. So this is not only a very powerful tool to query spatially and query your ingested data, but also is an international Open Geospatial Consortium standard, which means that the data you prepared and created within Azure Maps is not only accessible through our API and SDK, but also widely accessible through many other GIS and geospatial tools that you may be familiar with. And that's very powerful.
I love standards. I'm sure developers will be really receptive to that, considering that they might have invested in specific tools that will take advantage of these data sets created by Azure Maps Creator and other Azure Maps features.
Yeah, this is an incredibly interoperable way for creating maps and then using in multiple environments. One of the most common application of this query is looking for a room or an object. It could be a printer, for example. So you could use the name that you associated to it. You could further restrict or combine additional criteria, like I'm looking only for mid-sized meeting rooms or large printers, and you can get back not only the geometry, but all the metadata that you have been ingesting earlier on. And again, this is a super interoperable way to implement, find your printer, find your room, get there using a map. So this is a very, very common, we believe it's going to be a very common API in many different applications. In addition to that, to get to more robust data rendering, map data rendering, we also provide a new API to create your own tile sets. Azure Maps provides tile sets for every map we offer. But through this, you can actually create a fast delivery mechanism for maps in every mobile phone or web application. So using a very similar process, you can create a tile sets out of a data set. And as you go through the process, you get all the metadata that you will then use later for building a good well-configured map application.
Awesome.
You see here.
That's your way of getting performance on rendering for these kind of clients, right?
Yes, absolutely. It's a vector tile based. You can style more flexibly on the client and have many different experiences with the same data source.
Love it.
And it also helps in additional metadata, for example, to understand the extent, the bounding box, the zoom levels that are available to then use this map. So this is the basis for us to configure. Now, what if you have IoT devices that are bringing even more information at runtime regarding your spaces, your map objects that you already created? So this is where the feature state set is used to create this dynamic styling. Now, I can create a state set out of the same data set I'm working with. But in this case, I want to create a binding with what I know is going to come later. For example, I may have information about whether a room is occupied, or I may receive information about the temperature in each room. And here, not only I define that, but also how for each value or range of value, this map data should look like. This is what we call dynamic styling. It's the ability to reflect a new map on the client every time something changes through IoT observation.
I see. Yeah, it doesn't sound like rocket science, actually. It's pretty cool. I like that.
Very. And this is exactly the legend I was showing earlier. Let me show you. For example, this is basically the map I just created. Through this process is the building we were previously watching within a CAD data set. Now it's been brought in, and in this case, these colors represent the temperature that is currently measured for these given spaces. Now, I can go back and show you how you actually change the state. So first of all, we have an API to learn about the state. So in this case, the room that is identified with unit 23, which is this large space here, is currently is currently 66 degrees. Now, I can update the temperature for this. We could, for example, say it's going to be 79. And I give a timestamp. I continue identify this unit as the one I want to target for an update. This could be an update that technically comes from an IoT device. And if I query again the state of that particular room, it will tell me that the temperature has changed. And this would reflect the changes as well. So this is where you will see the temperature and the status being updated as things changes. As you see here, is flipping to a new color ramp, which represents the new temperature.
And the funny thing, interesting thing is that as an IoT solution developer, when I have a device updating its temperature in my IoT world, I just have a post request to send to have the data set updated. So it's like pretty straightforward. You can have very simple rules and push your data very easily from your IoT solution to update the visualization of that real-time data.
Yeah, that's exactly what is happening through the API, yes.
I love it.
And I hope this was helpful to get a sense of how to get there from a set of steps and API that actually power very powerful end results for spatial query, rendering, and more.
I like that a lot, and actually I like the name of the feature of the solution being Azure Maps Creator, because really it's about creating your own map with your own data sets. And this is actually, at the very beginning, I was hearing the name internally. I was like, oh, why are they calling that that? And actually now I get it better. I mean, like, you are becoming a creator of that visual space in terms of visualization and rendering and so on, thanks to Azure Maps Creator.
Absolutely. And things change. And through the API, you can keep maintaining your data up to date.
Awesome. So, Roberto, we have a short link for developers who want to get started. It's aka.ms/IoT show/Azure Maps Creator. That's where you're going to get all the information you're looking for to getting started, the samples, the guides. Well, I invite everyone to go there. Roberto, thanks a lot for coming on the show again, and hope to see you soon.
Thank you, Olivier. Thank you.
And thanks everyone for watching. Go to that link we just mentioned, and also do not forget to subscribe for the IoT show. See you soon.